I tend to speak loud. I don't know, guys, can you hear me? Are you guys good? It's a full house. It's like a party time here. So yes, it's good stuff. Thank you all for coming. I'm the Global Technology Manager for Electronic Materials at Sun, which includes the biosensor materials, which I'll be covering today. For those that don't know Sun Chemical, we're one of the largest ink and pigment companies in the world. We are part of the DIC Corporation with about 20,000 employees and 8.5 billion in sales. And we have a long history of ink manufacturing, ink development, as well as pigment technology. So even though the core business of Sun Chemical revolves around color, I don't really care about color. Don't mention that to our CEO or CTO. But we have a bunch of functional materials, whether it's for electronics applications or security applications, with some unique features that are not your typical graphics art applications or graphic inks. So the specific to electronics markets, we supply materials for PCB manufacturing. This is our image cure product line for solder mask and legendings, very traditional PCB shops are, our customers, as well as etch and plating resist. We do electronic materials for printed electronics, which are very relevant to this event. Electronic materials for biosensors, a topic for today. We also do through our through our parent company, we sell PSA tapes and foams for electronics assembly. And last but not least, we also offer etch and plating resist for and advanced dielectrics for solar wafer manufacturing or module assembly. We have a booth here, D3, so stop by if you have a chance and talk to us about any of these topics. But let's move on to our biosensor topic. So real quick, just kind of high level introduction of what is an electrochemical biosensor. Many of you probably know it already, but for those that don't, I want to kind of introduce it a little bit. So basically, they operate on the principle where chemical reaction induces a change in electrical signal, electrochemical sensor, right? So we have a target analyte that carries the molecules or groups that we want to analyze or detect. Then we have a biorecognition element or a capture molecule, I think you used the term. So biorecognition element on the sensor, and then a transducer, which is basically a converting element of that, which measures that change of the electrical signal. And then, so signal is generated and detected on a sensor, and then it's transferred to the instrument that analyzes the signal and the data. And there are various methods. Voltammetry, in EIS, right? Impedance spectroscopy, potentiometric. And within those categories, you have many other categories, and types of test methods and conditions that we use for characterization of our materials or our customers use for characterization and development of the sensors themselves. The target analytes could be biomolecules, bacteria, toxins, heavy metals, viruses and things like that. And the biorecognition elements could be graphene, right? Graphene layers, could be other nanomaterials, nucleic acids, enzymes, and things like that. So this is certainly not an all-inclusive list. There's a lot of functionalization that's happening on the surface of that sensing electrode or that working electrode. Applications range from the common ones, health monitoring and point of care diagnostics, to food safety, soil and water quality monitoring. So the applications are growing nowadays. Okay, next. Screen printing has been used for electrochemical sensors for many years, right? A lot of you guys know screen printing is used to print the base transducers or SPE, screen printed electrodes. So these are very often used for electrochemical sensors. The best example